Hi, I'm Veli from Greenwood Solutions. Now, I hate the cold, so this presentation is a bit of a strange one for me because it's about cold storage facilities and commercial solar. So after watching, you'll understand what energy is required to cool down a cold storage facility. What are some of the energy management strategies that a business can look at to combat their expenses, and how commercial solar directly addresses that expenditure from an electricity point of view. If you like what you see, hit that subscription button. Let's get stuck into it. Ready, steady, go. In this presentation, we'll be looking at the energy requirements for cold storage facilities from a commercial solar perspective. Now, the example we're going to use in this presentation is a facility of around 1,200 cubic metres. Now, on average, it takes 0.75 kilowatt hours a day to cool 1 cubic metre. So in this situation, the total kilowatt hours used per day is 900. So 900 kilowatt hours a day. So we're talking cold storage facilities, and in the case on the board we have a fish, perfectly drawn, and it's trying to eat a banana. We have milk, and we have a figure of 0.75 kilowatt hours per day to bring that space per cubic metre down to between 4 degrees centigrade and 0. Now obviously that's okay for milk, yes, and maybe butter and eggs and various things, but fish, if you were freezing fish, would be a much lower temperature, and that figure per cubic metre would actually go up. Now what's happened in the last few years is the height of these cold storage facilities have gone up, so the new builds are, instead of being 10 or 11 metres high, now 15 metres high. And with that presents a few problems in regards to commercial solar. So what's happened is the overall cubic area has increased, has gone up, but the available roof area has remained the same. So what's happening, you're getting more energy used per day, 900 kilowatt hours, than you were previously in the same surface area roof-wise. And that's the issue with the cold storage. You're using so much energy in this area that invariably in 9 cases out of 10, there's not enough roof area to completely negate those loads. So what happens very rarely is that energy is actually exported back to the grid because of that restriction on the roof size. Now, if there was a ground mount area, if it was an area for ground mount, it may be a different story. So you've got 900 kilowatt hours a day is how much energy is consumed. And on your bill, you pay, for example, 25 cents per kilowatt hour. And the cost to run per day for this facility is $225. And this equates to $82,125 every year for their electricity based on those prices. Now, the loads are usually of 2 main types in any business. The electrical loads, office loads, cold storage facility loads, which are the major loads, and then gas, natural LPG for office heating and hot water. Obviously, as a business owner, there is certain strategies that they can include in how they address their electrical expenses. So a full energy audit can be looked at. You can look at better cold storage software management systems, or after the analysis of the interval data and the average daily load of the premise, you can look at commercial solar. Now, average daily load is very important because it tells you how much the facility is using, but interval data will tell you when it's being used. So interval data is incredibly important when you're looking at any of these commercial sites, regardless whether it's a cold storage facility or an engineering firm or whatever it is. It is multiple snapshots of energy consumption on site, usually in half-hour increments if obtained from your smart meter. And it shows what's being consumed at, say, 8 p.m at 4:30 a.m. Why is interval data important? It's because getting a commercial solar system for your business, in this case a cold storage facility, is mainly based on financial considerations. If you're saving energy at a cost of 25 cents per kilowatt hour, you don't really want to sell excess at, say, 9 cents per kilowatt hour. By analysing the interval data, the commercial solar system designer can come up with the best system financially. This cold storage facility was quite small. It had an average daily load of over 600 kilowatt hours a day. The roof only allowed a maximum of 100 kilowatts of panels. So the question is, what direction and tilt to install the panels? So in this case, we looked at 100 kilowatt west facing at 10-degree pitch, and the payback was 5.7 years. In this case, we looked at 100 kilowatts east facing at 10 degrees, and the payback was a little bit better than west facing at 5.4 years. North facing, 100 kilowatt system at 10 degrees, you had a system payback of 5.2 years. So it obviously is the winner. Now, roof orientation and the viability of putting panels facing true north or facing east or northeast or west or northwest at different angles all plays a role. It's not only a case of producing the maximum amount of energy at the best orientation, and in the southern hemisphere that's north facing in all cases. In the case of a cold storage facility though, based on the fact that the roof is the restraining factor, ideally be facing them true north. Conclusion, cold storage loads are fairly stable. It takes 0.75 kilowatt hours a day to cool 1 by cubic metre. Commercial solar takes into account average daily loads and the interval data. Thanks so much for watching our presentation on cold storage and how commercial solar can directly address those electrical needs. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, or even any answers, please feel free to drop us a line. And if you like what you see, hit that subscription button. See you next time. Bye.